got a brand new car. Looks like a Jaguar. It's got leather seats. It's got a CD. Hey guys, so we're just going to do a review today of some of the stuff we've done on linear functions. And once again, this word functions I'm kind of throwing around. It is really a specific definition in math where when you graph an image, you'll notice that every x value has only one y value. And so that's actually the definition, or part of the definition of a function. And so linear functions, for the most part, are functions. There is a type of line we could draw that really wouldn't be a function. And I'll show you an example of that today. Once again, this word function really is important for those students that are going into, say, pre-calculus 11 and 12 down the road. But the grade 9 level, we just kind of throw it around just to get you sort of thinking about what it is, and don't really test you too heavily on that. What I would think right now as a grade 9 student is that if I use the word function, it's something you can graph. And so if you draw it, you're going to get an image. And this chapter, the only thing we've been drawing are lines. So it's basically really limits it to lines right now. But you can see lots of cool functions out there. And if you go on that program called Desmos I was talking about in an earlier video, then you can see many different types of shapes that can be drawn. For example, circles, so like a circle. If you think about that, that won't be a function actually, because for every x value, there's actually two y values, except for maybe at the sort of the edges of the circle sort of thing. And I'll draw a picture of that just to show you. Okay, so I'm going to share my screen here for my OneNote. And we're going to go just over some review. Not a lot of new stuff today, just kind of building what we've talked about here. Okay, so let's take a look. Flip this around, and there we go. Okay, now, last thing I need is my pen. So I'm going to pause this because I don't have my pen right now. Okay, I'm back again. I finally got my pen there. There we go. Okay, so what we're going to look at is two different ways to draw a line. And so one, it would be if the equation is written maybe something like this. So there's one way of writing a linear function you should be familiar with. And then another way you could write it, or not this specific function, but maybe a different function, and write it as like 2x minus 4y equals 8. So I'm pretty sure these are going to produce two different graphs. I haven't graphed them yet, but I'm assuming just looking at the numbers, they're going to give me different shapes here. Okay, so the first equation, y equals negative 2/3 x plus 1, we'd want to know the two properties of this. So this formula is written in that y equals mx plus b format. And if you can get your equation so the y is by itself, then I would use the slope-intercept method for graphing it. But you can see the second equation isn't as tidy as that, and so I'd have to do some rearranging. So I might use a different approach for that one. But let's do the first graph here. So my b value here is 1, and 1 will be the y-intercept. Now don't get this confused with the x-intercept. We actually don't know what the x-intercept is right now just by looking at that equation. I mean, it could be 1, but we really don't know. We'd have to do some calculations. And the m value, and I wrote this where the negative comes in front, because remember, m is the slope. Okay, so I'm going to use green for this graph, which I've chosen green here. So if you're in slope-intercept method, or sorry, form, then let's write up here, slope-intercept form. Then what I would do is I would find the y-intercept first, which is 1, and then I would graph the slope from this. Now, this can be tricky. Remember, slope is rise over run. And notice how I put the negative kind of outside of the function, like it's not with the 2 or the 3, it's kind of in front. And the reason I did that is when you write fractions, I would recommend that if you have a negative in front, that you do it or you look at it the middle way. I think that might make it more obvious to you. And so what I do now is I go to the y-intercept, and my rise over run is -2 over 3, which means it should be a downward sloping line. So that means I'm going to go down 2. So I go down 2, and I go over 3. 1, 2, 3. So I should have a point there, okay? And I should go down 2, 1, 2, 1, 2, 3. And I would say if you're using the slope-intercept method, you should do 3 points. And what you'll notice is they should all be on a line. Now, what if you looked at it the other way? Like, what if you looked at it as this way? Well, what that means is your slope would be up 2, but then you wouldn't go right 3, you go left 3, because it's a -3 there. So let's just show that. You go up 2 and left 3. 1, 2, 3. Up 2, 1, 2, left 3. I find that way a little bit more confusing because most students kind of generally, depends what country you come from, by the way, we read left to right. But some people from different countries read actually right to left. So that might be better for them to do it that way. I'm going to draw my line now. So I've got a bunch of points, and they all seem to follow this linear shape. And we get that line. So slope of -2/3, and a y-intercept of 1. Sorry. Okay, now should just also review here. Like, how did we know it was linear? So once again, some of you guys might just say, well, because everything in this chapter is a line, Mr. Dixon. But how do you know it's linear? Because in grade 12 and 11, you're going to have to know that. Well, the y is raised to the power of 1, and the x is raised to the power of 1. And so since both those terms, both those variables are to the first power, this will always produce a linear function here. Okay, so next question, we've got another linear function. But this method, the method for this, I'm going to use a slightly different approach. And the reason I'm going to use this other approach is because I noticed that all these numbers are divisible by even numbers. And so it's going to make non-fraction numbers appear here when I use the method. And so this method is looking at the intercept. So sometimes we just call this the intercept method. So I'm going to use purple here. And so let's call this the intercept method. Okay, so it's also referred to as ax plus by equals c. So let's find our x-intercept. And so if we're going to cross the x-axis, our y value would have to be negative. So I set the y value would be 0. So I'm going to set my y value to 0 here and solve for the x value, which will turn out to be the x-intercept. So here we go. So it's going to be 2x minus 4 times 0 equals 8. So that's really just 2x equals 8. So the x-intercept should be 8 divided by 2, which is 4. So I should have an x-intercept at 4, 0. So I go over to 1, 2, 3, 4. And now I'm going to find my y-intercept. And of course, if the graph crosses the y-axis, the x value has to be 0. So I'm going to set x equal to 0 now. And so I say 2 times 0 minus 4y is equal to 8. Now be a little bit careful here. 2 times 0 is 0, but notice there's a negative in front of that 4, like you're subtracting 4y. So you can't just get rid of it. It's going to be a negative 4y equals 8. And now I divide both sides by -4. So I divide this by -4. I divide this by -4. And I get y is equal to -2, which means there should be a y-intercept at 0, -2. Okay. Now, if I'm using this method of solving it, I'm really only going to get 2 points because there really is only going to be one x-intercept, one y-intercept. And so I need to be a bit more careful that I calculate this correctly. And so I'm going to have to rely on those 2 points being, um, being on the line. Ay, ay, ay. Sticky fingers. Okay, so there we go. So draw a line there. So there's my second equation there. Now, if you were maybe a little unsure about that, you can take the equation. We talked about this yesterday. You can take the equation and you can put it into slope-intercept form. So I'm going to subtract 2x from both sides, so -2x plus 8. And then I'm going to divide everything by -4. So y is equal to -2 divided by -4 is a half x, and then 8 divided by -4 is -2. Now I did that kind of quickly. I'll show more calculations in other videos, but let's see if that's actually true. Is our y-intercept at -2? And it looks like it is, -2. And is the slope 1/2? So you go up 1/2, up 1/2. So it seems to fit what we're looking at here. I just think the intercept method's a bit faster, but sometimes it's not great, and that would be if this is, say, a 7. So if that happened to be like an odd number, then you're going to get like lots of fractional numbers, and that's going to be really hard for you to plug in and calculate intercept values for, and even get them being close. But it still would work. It's just you'd be approximating the intercepts. So maybe the slope intercept would be a better method for you. Okay, so there's a few examples. Now I'm going to give you three other questions, all of which are kind of unique equations. And I'm going to graph them on the same grid. So let's plot that grid again. Okay, plunk that in there. Control V. There we go. So I'll move that over here. And here's three graphs I'd like you to try on your own here. Y equals 3. Then I'll go second equation, make it red. X equals -2. And the last one, number 3, is y is equal to x. This actually is a pretty important function here, especially in grade 12 math when we study inverses of functions. And some more other type of graphing problems. But maybe just pause the video here. I'd like you to graph those three and see if you can do them without watching me do them. And then we'll sort of show you them. Okay, so we just pause the video now. Okay, so for the first one, it says y equals 3. So notice that the form y equals mx plus b. If you think about slope-intercept form, there is no x term, which would mean the m value for this question would had to have been 0, because the x has vanished on us here. So the only way that would really technically vanish is if you times it by 0. So 0 times anything is 0. So our slope is 0, and so as a fraction, that's equal to 0/1 maybe. And so that means you would not go up any value, but you would go to the right by 1. And then you wouldn't go up any value, and you would go right by 1. And we also know that the b value would have to be 3 here. So I know there's a y-intercept at 3. And then I don't go up, but I go over. I don't go up, but I go over. I don't go up, but I go over. And so that would be a line, I guess, right? That's horizontal? Yeah, it's a horizontal line. So we did talk about this once again in another video, but it is kind of a weird one. I think it's strange. And I think what's strange about it, and I'm just going to see if I can draw it here. Oh my goodness. I'm going to give up using this ruler thing here. Okay, so it'd be a line that kind of looks like that. So this would be the line y equals 3. I know a lot of grade 11 and 12 students, even at that age, get this wrong all the time. And I think the confusion is that this is the x-axis and this is the y-axis. And students think, well, shouldn't it be x equals 3 if it's horizontal? Because the x-axis is horizontal. And what I want you to think about is along that line we just drew, the x values keep changing. Like this point right here, the x value is 1, and then the x value is 2, and the x value is 3, 4, 5, 6, and then -1, -2, -3, -4, and so on. And the x values are always changing, but what's not changing is the y values. The y values are always at 3. So for example, the coordinates of this point is 1, 3. Over here, if you were to plot that point over there, so we said -1, -2, -3, -4, -5, -6. This is -6, 3. So no matter what point you pick, it's always going to have a y value of 3. So really a line y equals any number will always be a horizontal line. And that will be quite useful for you if you're going into pre-calculus 11 and 12 down the road, and maybe even math 10 a little bit. I don't know if they do too much on that, but definitely in 11 and 12, you're going to see a lot of that. Okay, so our next equation is x equals -2. And so this is strange because you can't really look at it as the slope-intercept form. So and even with both these questions, you can't even use the intercept method to solve for them. So we know the x value is -2. So -2 would be here. And then what it's saying is that the x value is always -2. So it cannot change. It has to always be -2. So basically this point here, the x value is -2. This point, the x value is -2. Even down here, the x value is -2 here. So this would produce a vertical line. And once again, students get that kind of confused because they think, well, no, the vertical line is the y-axis. Shouldn't this be y equals -2? But this line here goes through -2, and every value on that line is -2. So this red line is the line x equals -2. So no matter where you go on that line and stop, your x value will always be -2, but the y value would always be changing. It would always be a different number. So where are we here? 1, 2, 3, 4, 5. So this here would be -2, 5. And down here, this would be 0, this would be -2, -2, 0. So you can see that no matter where you go on that line, it's always has a x value of -2. So anytime you have x equals a number, it's always going to be a vertical line. Okay. All right. Okay, so this next equation is it can be tricky depending how you decide to graph the equation. I'm going to get rid of my points here just so I don't have too much stuff on here, but I'll keep the red graph and the black graph here, and I'll switch over to this. Now, if you try to use the intercept method for this one, you're not going to be able to probably graph it just relying on the intercept method, because if you try to find the x-intercept, you make the y value 0. So you say 0 equals x. So there should be an x-intercept at 0. And if you try to find the y-intercept, well, then you make the x value 0, so you get y equals 0, which actually is the same point. And all that really means is that this graph goes through the origin of the graph. So I would not use that method to graph this. I would actually definitely use y equals mx plus b. And the reason for that is the b value here has to be 0, because there's no number on the end there. So it'd be plus 0. We don't normally write that in, but it would be plus 0. And the m value would be 1, which means the slope is 1 over 1. So up 1 over 1, up 1 over 1. I probably should say up 1, right 1, up 1, right 1, because depending on the country you come from, you might think of that backwards. Okay, so let's start at the intercept of 0, and we go up 1 over 1, up 1 over 1, up 1 over 1. So that's kind of what it looks like. Or if you want another way to write 1, by the way, and we talked about this in the other question, is you could say it's -1 over -1. That'd be a weird way to write it. but we know two negatives when you divide them make a positive. So you could go down one, then left one, down one, then left one, down one, then left one. But I think it's better to use the positives. I think students, so it clicks for students a bit better. Okay, so hopefully that kind of lined up nicely. Doesn't look too good. No, it looks pretty bad actually. Let's undo that. Let's move that a bit closer. That's not bad. Okay, so there we go. So there's our line y equals x. So there's our line y equals x. So there's sort of three unique lines. They're kind of different than the other ones you've been drawing. So you can get vertical lines, you can get horizontal lines, and you can get diagonal lines. But I guess many lines can be diagonal. Okay, so I was mentioning to you earlier, and that's the definition of a function is that every x value on the graph, every x value can have only one. Maybe we should underline the one part. I'm not sure which is more important. Have only one y value. Okay. So that is the sort of starting point for a definition of function. Once again, as you go deeper into math, this sort of make more sense why we're saying this. And I want you to think of those three pictures, and there's one of them that does not have that property to it, that every x value does not have only one y value. So basically, one of these three, this one, or this one of these is not a function. So can you guess which one that would be? Well, if you look at the green graph, every time I look at a point, this x value here has only one y value. This x value here has only one y value. This x value has only one y value, which would be that one right there. And this x value here has only one y value. So the green one is definitely a function. So this is a function. Okay, what about the black graph? Let's take a look. Well, the black graph, this x value has a y value of 3. So that's okay. This is a different x value right here. That has the same value of 3. But notice that every x value has a y value of 3, which is okay. It has one y value. So 3, y equals 3, sorry, is a function. So those are also functions. So what about the red graph, though? If you look at the red graph, we're starting at -2 right here, a bit bigger here. And notice that every value at -2 has many y values, actually. In fact, it has an infinite number of y values. So this second equation is not a function. And the reason for that is that every x value does not have just one y value. In fact, every x value, only being -2, has an infinite number of y values. So we set a circle, for example. If you were to draw a circle, I'll just draw my graph again. Control V. Okay. So let's just draw a random circle. I'm gonna give it a nice color. Let's make it blue. And what shape do I want? I want to do a circle. So there's a circle there. Okay. So what if we looked at that and we said, well, is that a function? Like why would it not be a function, or why would it be a function? Let's keep it blue. Blue. There we go. Right. Oh, come on. There we go. So now if I take a look at, say, this x value at 1, then there's a value here, and there's a value here. So this is about 1, 2. This is about, what do you think, 2.2 maybe on the y. And this would be -1, -2, -3, -4, -4.7 maybe for this point here on the y-axis. So notice that at 1, there's 2 different y values. And even over here at 3, there's another different set of y values. And so this is not a function. Now you could argue, if you go right on the side here, like right where it's kind of just at the edge there, there is only one y value there and one y value there. But when we ask whether it's a function or not, we're asking over the whole set of numbers you're graphing it. Does it hold true that every x value has only one y value? So circles are definitely not functions here. But lines, generally linear functions, are functions unless they're vertical, in which case they're not technically a function. Okay, so I'm just going to do one more video or one more question for you here from the homework. And that was where you had a line drawn. So let's say draw a line. And it kind of has maybe a weird, or not a very clear intercept here. So let's see. So maybe something like that, okay? And we draw a line and kind of, you're told to go through those points. So something like that, okay? And we're asking you, what is the equation of this line? What is the equation of that line there? Now, what you want to be careful of here is guessing something, like saying, I think it's this number. You actually have to prove that it is this number. So when I look at the graph, the y-intercept is not clear to me what it is. I mean, it looks like it's a little bit less than a half, but you can't just make up numbers here. So what I'm going to do is use our fancy dancy slope intercept formula, y equals mx plus b. Okay, and what I can't do here is say exactly what b is. I mean, I'm thinking it's 1.2, 1.3 around there, but I really don't know what it is. So we don't want to approximate the numbers here. So the b value you can't really find, but could you find the slope if you knew the 2 points? So basically, right now, cannot yet solve for b. So I can't yet solve for b. So I'm going to leave b alone right now. Can yet. How about cannot yet? How about that? There we go. Cannot yet solve for b. So what about the slope? So can we solve for slope? Can we solve? Well, if you know 2 points on the graph, you could use the slope formula, which is the rise over the run, which is y2 minus y1 all over x2 minus x1. So that's one way you could do it. Now, since you have the graph, you could actually just use the idea of rise over run also. You could just look at the graph and count how much up and how much over you went. And so I'm going to show you this 2 different ways. One is just using the graph. But you have to have with 2 points. We'll say graph with 2 points. Or the other method you could use would be using the coordinates of 2 points. And there's no really like a right way here. I think the algebra students out there will prefer the second one, and maybe more visual learners will prefer the first method for doing it. Okay, so let's sort of show you the first method here. So what I'm going to do now, I have to remember that slope is rise over run and not run over rise, because you could really botch this pretty quickly if you get that confused. So rise means to go up. So this looks like a positive slope for me because you're going upwards as you go from left to right. So I'm going to go up, 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 up until I'm at the high point of where that point is. Okay. And I'm just going to count how much I went over by or up by. So I went up 1, 2, 3, 4. So my rise, that would be my rise, is 4. So I rose 4 points. And then my run would be 1, 2, 3, 4, 5. So I have a run equal to 5. Okay, so my slope m is rise over run. So my rise was 4 and my run was 5. And if I have a graph, that makes it fairly easy for me to draw. So right now I could say y equals 4 over 5x plus b. Because remember, I don't know what b is yet. So I know I worked out the m value, but I don't know the b value yet. So that would be me done right now and then I have to find the b value, but I'm gonna stop with that one. And then with the other method, let's draw a line here, is I could use the formula here. So just draw a line. I could use the formula for slope, which is y2 minus y1 over x2 minus x1. And now I need to know the coordinates for this, though, so that does take a bit more time. So this point here is at 1, 2. So that's 2, comma 1, 2, 3. So 2, comma 3. And this point on the far side here was 1, 2, 3. So negative 3, comma negative 1. Negative 1 downwards. Okay, so I'm going to do y2 minus y1. So I'm going to make this x1, y1, x2, y2. Remember, you could do it the other way if you want. It's totally up to you. So my y2 is negative 1. Now I'm subtracting y1, which is 3. So you can see that's going to give you a number of 4, but negative 4. So I hope the bottom is going to be negative. And now I do x2, which is negative 3. And then I minus 2 from that. So the top gives me negative 1 minus 3 is negative 4. And then the bottom is negative 3 minus 2 is negative 5. And of course, the two negatives would cancel, giving us a slope of 4/5. So same answer, right? And so you get y is equal to 4/5 x plus a b value, a y-intercept value. Okay, so right now it doesn't really matter which way you did that. You would get the same initial setup here, slope of 4/5, and then you have to calculate out what the y-intercept is for your graph. Okay, so how do we do that then? So let's sort of draw a line under this, and maybe we'll sort of go. So now I got to figure out how am I going to get this this b value. And so once again, we talked about this in a previous video, is that if you're trying to find b, it doesn't really matter, you know, who you are. There's really no way to get b unless you know x and y. Like if someone said, what's the b value? I can't really do that unless I know x and y here. So I'm going to take a look at the 2 points I had. So I had the point negative 3, negative 1. And I had the other point 2 and 3, 2, comma 3. Now, I needed those points to solve the slope that way, but I didn't actually need those points to do this way. But now I am going to need those points. So basically, you would have to get those points at some point. Okay, that's a bad pun. Here we go. So now if I have time, I would check both numbers because I have to get the same b value. But if I was in a rush, I might choose the positive values because it's always easier to work with positive numbers. But I'll show you that it doesn't really matter which one you pick here. But I'm going to pick, so I'll say number 1 way of doing it would be to use the point 2, comma 3. Okay. So what I'm going to do now is I plug in 2 for x, and I plug in 3 for y. Okay. So I have 3 for y equals 4 over 5 multiplied by x, which is 2. But I'm going to write that 2 as 2 over 1 because I'm timesing by a fraction here, plus the b value. Okay. So 3 is equal to, I can't do any canceling there, so I'm going to get 8 over 5 plus b. Okay. Now, if you're comfortable working with fractions, you can do that. I'm going to try to reinforce this multiplying by the LCD, just because it's a really nice way to get rid of fractions, and it saves you a bit of time here. So I have times both sides by the LCD. So timesing it by the LCD, which in this case would be 5. Okay. and I times this side by 5. So whatever you do to one side, you have to do to the other side. So I times this by 5, and that gives me 15 equals times this fraction by 5. So 8 times 5 over 5. The 5s would cancel, leave me with 8 plus 5b. Okay, and then I subtract 8 from both sides, which is 7 equals 5b, and then I divide both sides by 5. So it's a pretty ugly y-intercept here. So the b value would equal 7/5, which is a bit more than 1, by the way, but it's not, it's hard to know what decimal number that number is without using a calculator. And of course, if you solve this just using, fractions, if you're kind of like, well, I don't like this LCD method, it's kind of like voodoo, I could bring over the 8 over 5. So I'm subtracting 8 over 5. That would equal b. I need common denominator now, so that's over 1. So times it by 5. So 15 over 5 minus 8 over 5 equals b. So 15 minus 8 is 7 over 5. So you could just use your fractional math if you're comfortable with that. And then the other way to do it would be using the negative point. And once again, if you have time, it's always good to check because you want to make sure you get the right number, although I've kind of gotten it right twice here. But I could go number 2, and I'm going to use the point -3, comma -1. So don't forget the first number is x, the second number is y. So I'm going to get -1 is equal to 4/5 multiplied by -3, which is really -3 over 1, plus the b value. So -1 is equal to -12 over 5 plus the b value. And then once again, just like before, I'm going to take both sides of the equation and multiply it by the LCD of 5. Now you could times by -5, but I'm just going to use 5 here. I'll times this side by 5. So I'm going to get -5 is equal to, now -12 over 5 times 5, the 5's cancel, so -12. And then I get plus 5b. I bring the 12 over, so I'm adding 12 to both sides. You can see you're going to get a 7 here. And 7 equals 5b. So divide both sides by 5. That's going to give us a b value equal to 7 over 5. Okay, so we get the same b value in all situations. So I think we're pretty confident that's the y-intercept. So what is the equation of the line? Well, we knew the slope was 4/5 x, and it has a y-intercept of -7/5. Okay, so that's actually a fairly hard one to get x and y intercepts for. So I'm hoping that kind of makes sense for you there. So I'm going to have a little worksheet attached to the homework section. So hopefully you'll get a chance to look through that, and hope you guys are doing well. Okay, so that's just mostly review today, but just kind of talking about functions and that kind of stuff. So let me just unshare this. There we go. Okay, so hope you guys, I guess I can always turn that on. Hello. There we go. There we go. Awesome. Okay, so hope you guys are doing well, and we'll do one more video the next day and probably assign some homework questions. So please just keep looking on the homework for a worksheet. I still have to type it out, so it might not be there right away, but it should be there soon.